Okay, let's start with chapter 9. Your chapter 9, 9.1 is differential equations. Oh my God, even writing is, you see, a bit difficult. Differential equations. Okay, what is differential equation? It's important to know what is differential equation. The definition for differential equation is an equation that contains an unknown function and also one or more derivatives in it. We call it differential equation. If I want to write this for you, a differential equation is, I'm pushing the mouse, is an equation that has unknown function and one or more derivatives. Correct? That's the definition of a differential equation. A differential equation is an equation that has an unknown function in it and one or more derivatives. A good example, for example, if I write for you y prime equals xy, or the easy one that you know it, dy over dx equals f of x. You see, is this a differential equation? How I can say it's a differential equation? I have a function. Here is your function. I have an unknown function in it. And also I have a derivatives in it. Do I have a derivatives in it? Where is the derivative? Here, dy dx is the derivative. Then an equation that has an unknown function and one or more derivatives in it, we call it a differential equation. Now, differential equations, they have also order. Like when you were in algebra, you had linear equations, quadratic equations, polynomial equations. They had order, right? Here, when we are dealing with the differential equations also has an order. How to know which order you are dealing with, or what is the order of a differential equation? The order of, again, I'm trying to write for you. The order of differential equation is the highest derivative Oh my God. I don't want to do mistake. When you do mistake, it's really difficult to correct. Okay. Sorry, because you need these notes. The order of differential equation is the highest derivative involved in the equation or occurs in the equation. This is the order. Some equations you will see the first derivative is involved. In some equations you see the second derivative will be involved. Some equations you will see the third derivative will be involved. Then how to know the order of differential equation? Which derivative is involved? We call that one the order. For example, if I write for you y double prime equals x times y, I will call this differential equation the second order differential equation. Or if I write y prime plus y double prime equals, for example, x plus y, I will call this differential equation the order equation because the highest is the second derivative. Of course, I have the first one, but the highest is the second one. I will call this one the second order derivative, correct? Any question up to here? Yes, no. Okay, now look at this example. Some of them, they're really easy to deal with. For example, if I have dy over dx equals f of x, I call this one a differential equation. Remember one thing that I forgot to tell you at the beginning of the lecture. In your book, we are just touching the differential equations. I'm not going to teach you differential equations in this course because most of you that you are aware that we have a separate book by name Differential Equations, which is a full semester, and we will teach you there everything about differential equations. Here in this course, we are just dealing with the very simple form of this differential equations and give you an idea what is differential equation, correct? Okay, anyway, dy over dx equal f of x is a differential equation. Like I told you, there is an unknown function and there is a derivative involved, then this one is a differential equation. How to solve a differential equation, or what is the answer for a differential equation? Remember, the answer for a differential equation is always a function, not a number. The answer for a differential equation is always a function, not an answer. When you solve a differential equation, it means your solution is a function. Look, for example, here, if I want to solve this equation, if I do this, what do you think? I will end up, what is the integral of dy over dx? The integral of dy dx is y equals integral of f of x dx. It means for the first degree, for the equations that they have only one variable in terms of x, they're really easy to solve. Just take the antiderivative or take the integration, y equals something, it gives you a function, and that's your answer. But unfortunately, it's not going to happen every time. They are not this easy. They have different types, and some of them you have to work to find that function, correct? But this is an idea. What is the answer for a differential equation? The answer for a differential equation is a function, always a function. Any question? Don't keep the questions with you. If you have a question, please ask me. Do you want to see a quick example here for this? Let me show you an example here.
All right.
For example, if I give you y prime equals x to the power of 3. Is this first a differential equation? Do I have a function? Yes.
Yes.
You see, f of x equal x cubed is a function. Do I have a derivative involved in this equation?
Yep.
Yes. What is the order of this equation? It's order 1, right?
Yep.
Because the first derivative is involved. This equation is the order 1 differential equation. Now, how to solve this? It means take the integral from both sides. You can write the integral of y prime equals integral of x cubed and dx, of course. What is the integral of y prime?
Y.
Y equals, what is the integral of x cubed? I know everyone forgot about how to do this integral. Now you need to go and check the book, right? You are adding 1 to exponent and divide by new power, right?
X
That means your answer is here x to the power of 4 over what?
4.
4. Is y equal x to the power of 4 over 4 is a function?
Mm-hmm.
Yes. You see that the answer of a differential equation is always another function. And it, of course, here what I missed as usual.
Oh, right. C.
Plus c. Because it's not a definite integral, it's infinite, right? That's why I forgot plus c. I have to put plus c. Let me explain something here for you, why that plus c was very important at the time that we studied integrals. Plus c means one of the answers of this differential equation is x to the power of 4 over 4. But there is a family of the functions that can be the answer for this given differential equation, because c is a constant. C can change to different numbers, right? It means a differential equation can have, if it's not in general form, can have a family of the answer. It's really important to put this C in your answer, correct? Do not miss this C, please. Now, question?
Mm-mm.
No? Yes?
No.
Okay, example number 1. Show that every number of the family of the functions y equals 1 plus c e to the power of t over 1 minus ce to the power of t is a solution of the differential equation y prime equals 1/2 of y squared minus 1. Actually, they are telling you to show that this is one of the answers of this equation. It's a kind of proof. You want to prove it that y equal 1 plus CE to the power of t over 1 minus CE to the power of t is a solution of y prime equals 1/2 y squared minus 1. Now, how to solve this problem? Step 1. And step 1, find the derivative, the first derivative of this given function, correct? Which rule is that? Do you remember your derivatives still? It's a quotient rule. I'm using the quotient rule. Then y prime equals. If you don't remember the quotient rule, let me write the quotient rule in a different color here for you. Okay, how to change the color? Let me see if I can change the color. Maybe this one? No. Here, your quotient rule. Your quotient rule was G F prime minus F G prime over G squared. Remember? That was your quotient rule. Now, G, it means 1 minus C E to the power of t times F prime. What is the derivative of the numerator? C is a constant. 1 is a constant, right? The derivative of 1 becomes 0. The derivative of CE to the t gives you CE to the t over minus. Now F, what is your F? 1 plus CE to the t times the derivative of the bottom gives you negative CE to the t, all over 1 minus CE to the t, all squared. Simplify a little bit the top. It means distribute CE to the t to this parenthesis here and distribute negative CE to the t here in this parenthesis. Then y prime equals CE to the t times 1 gives you CE to the t minus CE to the t times CE to the t. Anyone who want to give me the answer? CE to the t times CE to the t gives you what? Any answer? CE to the t times CE to the t gives you C squared E to the what?
T squared.
2t. Correct? Plus, you see negative times negative gives you positive.
Yeah, it's going to make a positive.
CE to the t times 1 gives you CE to the t. Again, negative times negative, positive, positive times positive gives you another positive. CE to the t times CE to the t gives you C squared E to the 2t. All over your denominator, which is 1 minus CE to the t, all squared. From here, do you see I have CE to the t here, CE to the t here, it becomes 2 CE to the t. I have negative C squared E to the t here, positive here, they cancel out. Then my answer is 2 CE to the power of t over 1 minus CE to the power of t squared. Any question up to this step? Any question up to this step?
Nope.
Okay.
No.
No, no question. Now, in step 2, why my pen is not working again. In step 2, the equation that it's given to you, which is y prime equals 1/2 of y squared minus 1. What I do, I'll plug the value of y here and I will simplify. You see how much is y? The y is given to you. The y is given as a 1 plus ce to the t over 1 minus ce to the t. I'll take this value and I'll plug it here in y, correct? Then I can write y prime equals 1/2 parentheses, what was y? 1 plus ce to the t over 1 minus ce to the t all square minus 1. Let me put a bracket here because I have 1/2 there. Then y prime equals, square this, 1/2 times, can I write this one as a square of the top over a square of the bottom? It means 1 plus c e to the t all square over 1 minus c e to the t all square minus 1. Correct? Now, what I need here, I need a common denominator between 1 and this fraction. Then I can write this one as a 1/2 bracket parentheses 1 plus c e to the power of t all square over 1 minus c e to the power of t all square minus, because I have 1, I have to multiply this fraction with 1 minus c e to the power of t square. It means here I will get 1 minus c e to the power of t square, also denominator 1 minus c e to the power of t all square. Any question up to this step? Yes, no, please.
Oh, I'm good.
Good, okay. Now let's simplify this part, right? Then I can write y prime equals 1/2 bracket, a big fraction bar. What is 1 plus c e to the power of t all square? Use a plus b all square formula. It means the square of the first, which is 1, plus 2 times 1 times c e to the power of t, which gives you 2c e to the power of t, plus the square of this part, which gives you c squared e to the power of 2t, minus, same thing, FOIL this, it gives you 1 minus 2 ce to the power of t plus c squared e to the 2t, all over 1 minus c e to the power of t all square. Now distribute the negative here to inside. Then y prime equals 1/2 bracket 1 plus 2 c e to the power of t plus c squared e is e to the power of 2t minus 1 plus 2c e to the power of t minus c squared e to the power of 2t all over 1 minus c e to the power of t all squared. Now, positive 1, negative 1, 0. C squared e to the 2t, negative c squared a to the 2t cancels out. What left? Y prime equals 1 over can I multiply it right now or I should wait? Well, let me wait. 1/2 times what left inside? 2c e to the power of t, 2c e to the power of t gives you 4c e to the power of t over your denominator, which is 1 minus c e to the power of t all squared. Can I simplify this 2 with the top? 2 goes 2 times to 4. Then I can write y prime equals 2c e to the power of t over 1 minus c e to the power of t all squared. What do you see here? The derivative of the given function is equal the derivative that you found at the beginning here, you see? They are the same. When you deal with this, you found the derivative of y, and when you plug y here and you found the derivative and you simplify it, they are the same. It means that you show actually that this given y equal to c e to the power of t over 1 minus c e to the power of t all squared is a solution, or one of the solutions, correct? Is one of the solution of the given differential equation. These problems as a kind of proof, but soon as I jump to separable differential equation, it gets a little bit easier. The first part, it's kind of complicated in this problem because they ask you to prove. They ask you at the beginning, prove that this equation is a solution of this. And you did it. And you proved that this equation is the same as that one, right? Even not necessary to write plus c here because it's just a proof. You proved it, correct? Any question on this problem? Yes, no?
No,
No.
it seems pretty straightforward. A bit.
Yeah, it's not that difficult, believe me, it's not that difficult. It's really gets easy for you because I told you that I'm not going to teach you differential equations, right? It's a full book. But at least I'll give you, because it's in your chapter 9, we will give you a kind of overview of the differential equations. Any question? Okay. This is your first day, and actually we are almost done with the class. I will also record this lecture with a whiteboard with marker. I'll do more examples maybe there, and I'll send the link for you. and you will receive all these videos. Please practice with this. Let me know if it works for you this way. For my Norco College class, it worked really well. They're really happy. Just send me your ideas if this way is working for you. At least I can do this much for you. But if you have a better idea, just let me know. Any question on all the issues that discussed today or about the lecture?
No.
No, not
Yes
for
or
me.
no?
No, this format seems pretty fine.
Okay. Let me see. No. Okay. Now I'll stop the meeting here. Thank you for coming online. If you see it works for you, if you have time, please come on time online. It is my responsibility to be online at this hour because it's my class. I will not miss any day. You will see me here behind computer in my office, and I'm here to do lectures. And if you have a question, don't hesitate, don't keep it with you. Ask me the question, correct?
I have a question.
Uh-huh.
How soon after will you have the lecture posted on Canvas?
This Zoom will take a little bit time. Sometimes they send you immediately back the video. Sometimes it takes them like 2 days to send. But definitely after I finish this class, I have another college algebra class. And after that, I can upload my video that I do the same lecture on the whiteboard. I'll upload that one for you. And you will receive that one very fast. By tomorrow, you will have again the video of the lecture.
All right.
And I don't even think that you could post it, but if I remember correctly from another class that did it, is that if you go to that same spot from Comfort Zoom where today's lecture should be, you just scroll down and then there's just a bunch of different file formats for you to watch this recording.
Yeah, you have the typing, the audio, also the written format, and also the video. But believe me, I'm dealing with this since 2 weeks or 3 weeks. I know sometimes it takes time for the Zoom to do this because everyone is using Zoom right now. Sometimes it's really fast, correct?
Okay.
If you see it fast, you are lucky. You will see it today. But anyway, don't worry, I'll do another lecture for you, the same lecture on the whiteboard. That one is much better than this. Hopefully, you will receive that one too. It's more work for me, guys, not for you.
And we thank you for it.
Any other question?
No, sounds good.
Okay, if you don't have a question, be safe, stay home. You know, my friends are walking around. I'm really kind of seeing you, watching you. If I get aware that you are going out for a party, then I will assign a lot of homework to keep you safe at home, right? Stay home, be safe. See you Wednesday at this time.
Thank you.
Thank you.
Thank you. Thank you. Have a good one.
Welcome, guys.